In this video, we will see the horizontal asymptote of rational functions. In our previous video, we already saw that a rational function is a function that can be written as the ratio of two polynomials. For example, the polynomials x and x plus 1. We also saw that an asymptote is a line that the graph of a function approaches but never touches. Now we are going to see specifically the horizontal asymptote of a rational function. This is an horizontal line that a graph approaches but never touches. If we see this example, we have the function 1 over x. And if we pay attention to the blue curves that we have in the graph, the lines are approaching an horizontal line that they don't touch. In this case, it's this line that corresponds to the line y equals 0. This is the horizontal asymptote of this function. Now let's see how to determine the horizontal asymptote when we have the function. What we first have to do is to compare the degrees of the polynomials in the numerator and in the denominator. And then once we know the degrees, we need to check which one is larger than the other. If the degree of the numerator is greater than the one of the denominator, that means that it doesn't have an asymptote. If the degrees of the numerator and denominators are the same, that means that they do have an horizontal asymptote in y equals a1 over a2. A represents the coefficient of the first term of each polynomial, the one that has the greatest power. And if the degree of the numerator is smaller than the degree of the denominator, that means that its asymptote is in y equals 0. Let's see examples of each. Find the horizontal asymptote of the function f of x equals 4 over x plus 1. First, we have to determine the degrees of the numerator and the denominator. In this case, the numerator is 4. That would be a 0-degree polynomial because it's only the constant term. It doesn't have a variable. And the denominator, x plus 1, that corresponds to a first-degree polynomial because its greatest exponent is 1. If we compare the powers 0 and first degree, we see that the degree of the numerator is smaller than the degree of the denominator. That corresponds to the third case, which means that the asymptote is the line y equals 0. If we see the graph of this function, we can see that the horizontal asymptote is in y equals 0. Let's see a different example. Find the horizontal asymptote of the function f of x equals x squared over x minus 1. First, we check the degrees of the numerator and the denominator. In this example, the degree of the numerator is second degree, and the degree of the denominator is first degree. If we compare them, now the numerator is greater than the degree of the denominator. That would be the first case. That means that this function has no horizontal asymptote. If we see now the graph of this function, we can see that in fact it doesn't have an horizontal asymptote. This actually has a different type of asymptote, which is called a slant asymptote. It would be something like this, okay, which is not an horizontal asymptote, so we are correct. Now let's see another example. We need to find the horizontal asymptote of the function x plus 1 over 2x. We check the degrees of the numerator and the denominator. The degree of this numerator is first degree, and the degree of the denominator is also first degree. If we compare them, we see that they are the same degree. That would be the second case, where it does have an horizontal asymptote in y equals a1 over a2. a1 corresponds to the coefficient of the first term of the numerator, and a2 corresponds to the first term of the polynomial in the denominator. That in this case is only one term. So the coefficient of x is 1, and the coefficient of 2x is 2. That means that the asymptote of this function is in 1 over 2, in y equals 1/2. If we see the graph of this polynomial, we see that in fact the horizontal asymptote is in y equals 1/2. Let's see our last example. We have the function 2x squared plus 1 over 3x squared, and we need to find the horizontal asymptote. So first we check the degrees of the numerator and the denominator. Degree of the numerator is second degree, and the degree of the denominator is second degree as well. So just as in the previous example, we have the same degree in numerator and denominator. That would be the second case. So we check the coefficients of the first term, and in this case we have 2 and 3. That means that the horizontal asymptote of this function is the line y equals 2 over 3. We can see the graph here, and we see that we are correct that the horizontal asymptote is in y equals 2 over 3. Now you know that to determine the horizontal asymptote of a rational function, we compare the degrees of the numerator and the denominator to tell if it has an horizontal asymptote, and if it does, to determine where it is. Thank you for watching this video.